Okay, so hello guys, I'm David. I'm from Cesnet, and I'm presenting you the journey that we had to take to make 400G monitoring using DPDK and FPGA chips possible. So, to introduce Cesnet, it is a national research and educational network, and it has a department of administration and security tools, which I work in. So basically, you can imagine Cesnet as an organization with the research network, and the department that I work in, we design FPGA NICs with DPDK support and create solution for monitoring, DDoS mitigation, and hardware acceleration in general. And we are also known as the Live Router project. To introduce a bit more why we need to use, why we need to do the 400G monitoring, I have this picture of Czech Republic and the visualization of Czech network. And if you can see the blue lines, these are the lines with 400G throughput, which we need to monitor. So we have to come up with an idea how to do it. And before I start talking about how we did the monitoring, I want to say a few words about monitoring in general. So if anyone doesn't really know this topic or would like a bit of an introduction, there it is. So to monitor a line, we usually use a tap device to clone the traffic to Ethernet ports of the card, and we also use a application, usually with DPDK, since we work on very high speed, such as 100G or 400G. And we also like to pre-process the traffic in FPGA. So we have some kind of application core in the FPGA chip, which we can offload some rules to. Now our journey with how to do the monitoring begins with the hardware, since back then when we tried to make the 400G monitoring possible, there were no FPGA card in the market, so we created one or designed one. It was manufactured by the Reflexes company, and it was also the first FPGA SmartNIC on the market. It uses Intel Agilex 7 chip, and of course it has the 400G Internet. It supports PCI Gen 4 or 5 and more endpoints, since Gen 4 has low throughput, so to get 400G on Gen 4 you need at least 2 endpoints of that card, or like the card with 2 endpoints of PCI. So that would be the hardware. Now about firmware. What are the requirements? Well, we need to process every frame, every circa 1.25 nanoseconds, which means that we need to use parallelism, process at least 4 frames per cycle, and have a high bus granularity. And of course, it's nice to have fast firmware, but we also need to be able to offload the tasks to the hardware, so parsing, filtering, and metadata supports are also a must. To do that, we created NDK platform, which is actually open source platform, and supports up to 400G. It uses a concept of our own buses, in which we can process multiple frames per clock cycle, and it supports mentioned filters and export of metadata. And it's also easy to create new components to this platform, so anyone who creates firmwares using NDK can use then the new components in the processing pipeline. When it comes to firmwares, I don't want you to think that NDK is only for monitoring. We aim to do more than one use case. So we also use the NDK firmwares for high-frequency trading, load testing, and many more. And we have our commercial partner, Brno Logic, that creates on-demand firmware with using the NDK platform. So the NDK platform doesn't support just creating monitoring firmwares, but much more. And it's not also platform to create firmware for 400G. We support many cards for various use cases. For example, the Silicom N6010. That card is it has 2 Ethernet ports with the 100G speed. So this can be used, or many other cards from, for example, AMD/Xilinx. But NDK is not only the firmware platform, we have software bundle as well. So we have the kernel driver in Linux. I mean, not in Linux, I mean upstream, but we have the driver and we have the pull mode driver in DPDK. So any card or any firmware that is using the NDK platform has the DPDK support as well. So it's always nice to have. Good to mention is that if you would look at the DPDK upstream, you wouldn't find any RTE flow or metadata dynamic fields, which are we currently using, because it's not yet upstreamed, but we are hoping to change that in near future. Now, when we're talking about NDK platform, I would like to also mention a bit about the verification process. The NDK platform is verified very thoroughly, but I thought I would at least introduce this case where we verify the NDK firmware using DPDK. There are 2 pictures. One is the typical DPDK use case where there is our pull mode driver using our NFB library to access kernel and the hardware using PCI bus. And right there is the simulation case where we need to use VDEV driver to inject special device handler that injects gRPC extension of our library, so we can kind of create this server client architecture using gRPC to get the input to the simulation. And so we have to do that once more to simulate RAM. So the simulator has also input from the DMAs. So this would be the simulation of DMAs, and this one, the normal configuration. Okay, back to our 400G SmartNIC. It's supported by the NDK platform. So just to sum it up, it has the DPDK support, and the FPGA card is capable of accelerating the monitoring process at 400G. It also has the monitoring capabilities needed to do that. The most important ones for us are marking, dropping, and exporting the metadata, so we can pre-process the traffic in the hardware, and we can drop some unwanted traffic that isn't so important to us. And yeah, so that would be the hardware, firmware, and low-level software. Now I would like to talk a bit about the monitoring applications. We use more of them, but this one is open, so I can talk about it. IPFX probe is also open source. It's developed by us, and it has the DPDK support, so it can be used as the probe of the wall concept and creates byflows from the input packets. Now a few words about testing, how we test the card. We usually do functional testing, which is this picture above, where we have the test PMD or some kind of custom DPDK application, since not everything can be tested using TestPMD, for example, the dynamic fields or dynamic flags. And we use Ethernet loopback to get the traffic back to the card, so we can test it in one server, or we do the benchmark tests where we use an external traffic generator. For that we use Spirent, which I believe many of you know, but flow test you might not know, since it's quite a new tool and is also developed by us. It's actually a complex testbed, so it can be, it's mainly used to test probes. It has the orchestration tool and traffic generator, and then the collector and analyzer. So it verifies that the output of the probe is matching the inputs. But it's modular, so we can use also just the flow test generator to test the card without any probe. So that's great. And we also it's also worth mentioning that it includes generation that is capable of simulating realistic networks. So it isn't just some artificial traffic, but traffic much more closer to real traffic. And if you remember when I was saying that NDK supports the creating of custom components, this is one of them. It's called Connection Tracking Table, or CTT for short. And what it does, that it receives packets in the hardware, drops them, and creates records. And when the flow of received packets ends, it exports the records to the probe, and this way we can offload the work to the probe. And I think it's a very nice solution, especially for the long flow that lasts several minutes. A few more words about the connection tracking table. Currently, it's not supported by RTE flow, since we couldn't find any rule that would fully match our use case, especially when it comes to exporting the records when we use the special kind of packets. And we don't use them we don't send them by querying, but when the CTT in the firmware decides that the flow has ended. And it's also nice to say that it's easy to change the firmware, so we can change the matched packets, and so we can change how many flows will be, or which flows will be matched and processed by the CTT, and which where we passed through to the software where the probe is. And yes, that's everything. Thank you for your attention. And I would like to mention all these links, since we love open source. So you have GitHub links for the IPFix probe, NDK app, minimal, which is, I would say, the rabbit hole to the NDK platform. Flow test, the testing tool, and our commercial partners, Logic and ReflexTest. Yeah, that's all. Thank you very much. Sure, what would you want to hear? Well, this is a probe that we use. It doesn't have the DPDK support, but it works as well with our own API, and we use that for monitoring. As I said, it's not the only probe we use, but it's one that Cesnet developed, so, and it's open source, so I thought it would be nice to say.
Is there a graphical application?
I'm sorry?
Is there a graphical interface, or is it just on the server?
I think it's just command line.
Just command line, okay. And your other project, which is flow test.
Yes, flow test.
Is it command line as well?
Yes, I think so.
Okay. So you developed a new traffic generator?
Yes, we did.
Why?
To simulate real traffic, because this, well, we had problems testing our probes, and we thought that if we can catch some traffic in our network and then create records that can be replayable, that would be the best option.
Okay, but did you check the other traffic generator on top of DPDK? There are quite some.
I'm not sure. This flow test project is not something that I worked on, so I can really tell you more about the process.
Okay, so that's something to check. If there are some tools useful for the DPDK community, I would suggest to list them on the DPDK website. We have a section for that in the ecosystem page. Well, one last thing, you said that you didn't find any RT flow rule for your connection tracking packet?
Yes.
Because that's a special protocol that you invented?
Yeah, well, yeah.
So in this case, there is a rule. There is some field called row, RT flow row, something like that. So you can completely define your packet. Maybe it can match your need.
All right, I will look at it.
Thomas, this is for you. If I remember correctly, there was in Bluefield 2, there was state flow table which did something. Connection tracking, TCP connection tracking and all, right?
Yeah, there is a contract implementation in Bluefield. But there's a standard contract. Yeah. Javin?
Yes. Well, the IP fix probe. Our use cases that we usually, where is the best? Yeah. We usually filter out some traffic in the firmware, so it receives, let's say, 70-60% of the traffic, and that is then monitored. Usually, depends on the use case. Yeah. Yeah. I'm sorry, I don't have the right data, but I can send it to you later.
So,
yes. I think it worked as it is because it's used for, well, before the 400G card, we used it on our other cards that had the lower throughput, but the API was still the same.
the app core, what kind of processor is this? It's a RISC-V or?
Yeah, well, that's the processing that we do in FPGA chip, and it varies. It depends on the firmware that we load. But usually in this scenario, we filter out some traffic using basically IP addresses or ports, and then we export some extra metadata such as timestamp or marks that help the processing in the software.
It's a RISC. What kind of CPU core?
It's FPGA.
Okay, but which architecture?
What do you mean?
Is it what kind of is it a CPU core or?
No, it's FPGA chip.
Okay. It's a fixed function hardware then.
Yeah. sorry, can you use the microphone?
How do you hook the traffic for IP fixed probe?
How do you mean hook?
Where do you get the traffic? Like we have a line or fiber or something else?
Yeah, fiber line and using the optical tap device to clone the traffic.
I mean, if we do something like a fully hardware offloaded traffic, can you capture it?
I'm sorry, can you repeat the question?
If the software is totally unaware of the traffic, can you capture it?
If the software is so what?
Unaware of the traffic. No CPU cycle, no buffer in software side. All in the hardware, like switch.
Okay.
Can you capture it?
Not really. We only pre-process the traffic in the firmware.
Okay, thank you.
So you mentioned about NDK, right? So what is the use of NDK? Like, can we change the firmware using NDK?
I'm sorry?
Can we change the firmware of this app core?
Yes, that's what it is used. It's used to create the app core. So you have you can use some components that are there or create some new one as the CTT I talked about.
Is it something like P4 kind of?
Yeah, but it's a VHDL platform, so a bit more low level.
Bit more low level. Okay, and like let's say I want to create a new parsing logic. I want those kind of things I can do with NDK or like?
Yes.
I see. Okay, thanks.
No more question? Okay, let's thank our speaker.
Thanks for having me.